All right, hi everybody. This is our first presentation in unit number 4. So we'll be talking about mass, volume, and density. So this is a unit where we will start to go from our physics unit to our chemistry unit. So mass, volume, and density and the buoyant force that we're going to be talking about next week is kind of our good transition from going from physics to chemistry. So let's get started.
Remember, you should have a highlighter out at all times. So the first one that we're going to talk about is mass, right? And I don't want you to confuse this with weight. We'll talk a little bit more about weight, but mass is basically the amount of stuff, or the key term is matter, that makes up an object. So when you step on a scale, what you're actually really finding out is your mass. It's not really your weight. You're finding out how much matter is inside of you. So when someone says, "Oh, I weigh 160 pounds," what they're saying is I have 160 pounds worth of mass or matter that makes up my body. All right, we measure this in grams, kilograms, pounds. That's what you know as. But in this class, we're going to be using mostly grams. We're going to be measuring a little bit small stuff. We won't really be doing anything in kilograms, but grams mostly. And we use a scale. You've been using the scale all year long, so that shouldn't be anything new to you guys. But really what we're finding is the mass of an object when you do that. Okay? So what is the difference then between mass and weight? Okay? Well, weight, it depends on gravity. And that's the biggest thing that I need to say is it depends on gravity. And the reason why we use mass and weight the same basically on Earth is because the gravity, we base everything off of Earth's gravity. So when somebody weighs 160 pounds here on Earth, they also have the mass of 160 pounds. All right? Now, mass, the biggest thing is your mass always stays the same. It does not depend on gravity. Right? So for example, let's say that I travel into space, all right, where they say you have zero gravity. You really don't weigh anything in space. Like if I were to step on a scale and to measure, I would weigh 0 grams, right? However, my mass doesn't. My mass still stays 160 grams. Okay, it's not like all of a sudden I shrink to this nothing. Okay, so it really doesn't, my mass never ever changes. So the amount of matter that's inside of me doesn't change no matter where I go, wherever I travel in space. But my weight does if I were to go to a different planet or anywhere else. Okay, for example, I wrote on Earth my mass equals 150 pounds. At the bottom right here. If I travel to the moon, does my mass change? Does my weight change? Okay, and the answer is my mass stays the same, right? But my weight definitely changes because the moon has 1/3 the gravity of Earth. So it would actually end up only weighing 50 pounds on the moon. Now, that doesn't mean that all of a sudden I shrink to become this little tiny 50-pound person. All right, I still look like me. I still look like, or you'd still look like you. You'd still be like, whatever, if you're 6 foot tall, that person would still look like they're 6 foot tall. It just means that gravity's pulling on them a little bit less. So that means they weigh a little bit different. So that's the difference between mass and weight. Right, so the next vocabulary word that we need to talk about when we're talking about when things are sinking and floating is volume. All right, and volume is the amount of space an object takes up. All right, so how basically the key thing is how big is that object. So when someone says, "Wow, that's a large object," what they're really saying is that has a lot of volume. Okay, or when someone says, "Ooh, that object is really tiny," what they're really saying is, "Oh, that's a very small volume." So that's what I'm going to be saying. I'm not going to say large and big like that. I'm going to say small volume or a large volume. So how big is that object? And what we're going to be using is more like in our class is cubic centimeters and milliliters. Those are the two units that we'll be measuring objects in. All right, and this little picture just shows like how cubic centimeter equals 1 milliliter. Like if I measured something that was a cubic centimeter, so like a cube, that's 1 centimeters each side. If I were to melt that, it would actually turn into a liquid that would be 1 milliliters. So that's how they came up with the 1 milliliters equals 1 cubic centimeters. All right, that'll make more sense when you're talking about, because we're going to be measuring liquids and like solid objects.
All right, so the first way that we can find the volume of an object is if it's a liquid, right? And we're going to talk about 3 different ways to find the volume of an object. All right, one is if you have a volume of a liquid, what can you do to make it, how can you find out how much volume? And we've done this before, so this is not something new that you've done, but it's just to reiterate how you would go about doing this. So this is just water with blue food coloring in it. And again, what we learned before was we can use a graduated cylinder, right, to do this. Now, there are many different sizes in a graduated cylinder, and we talked about this in regards to there is a larger one, and then there are some couple smaller ones. So this one's a 10 milliliter, this one's a 25, and this one is a 50 milliliter graduated cylinder. And the idea is when I try to find the volume of this, I want to use the smallest one of these as possible. Okay, so if I look at this, and I don't know if you can clearly see this, it's pretty close to about 20 milliliters. All right, so I know that I can't use a 10 milliliter one, right? So I'm just going to get rid of this one right now. So it's clearly between the 25 and the 50. Because I see that this is just barely above the 20 milliliter line, I'm probably going to end up getting rid of the 50 milliliter one and using the 25. All right, so then I'm going to pour this into here, right? And then I'm going to read this so that I can see. Now, I want to make sure that you see what I'm seeing. All right, so when I pull this down, you can clearly see that I want to make sure that I want to read this at eye level. So if you see this, and hopefully it will, you can clearly see that it's roughly at about, let's see, 19.5, 19. It's at 18.5 milliliters. So I'm going to make sure that I am at eye level when I do this, and I clearly see that it's at 18.5 milliliters on this thing. So that's how I would find the volume of a liquid. Is I would clearly, if I'm looking at this, right, I would have my choice of these 3, and the one that would make the best fit is this one. I don't want to use, even though the liquid would fit inside this one, the 50 milliliter one, I'm not going to use it because this one is the most accurate of the 3 that I could choose. Alright, so the second way that you can measure volume is dependent on what it looks like. So for example, in the first one we talked about liquids, alright, but now let's talk about solids, alright, like things like these 2 things that I have holding right here. So one way to do it is through what's called length times width times height. All right, you probably might have learned this in math class already. So I always like to write it as a short term, like V equals L times W times H. All right, now this only works for rectangular solids. Okay, you can't do this for every type of solid item. For example, if I have this little piece of clay right here, I couldn't do this for an object that looked like this because it doesn't have a definite width, length, or height because it's got curves to it that does that. Same thing, like for example, the pen that I'm using right now to do my recording. I can't use length times width times height for an object like this. Okay, I can only use it for objects that look like this, a box shape. All right, so it's a rectangular prism of some kind. So in this case, my tool that I'm using is a ruler, and all I would do, right, is, as you can see from here, I would just measure, right, my length, my width. So like if I call this my length, and if I call this my height, and I call this my width, right here, I would just get those 3 numbers, and then I would solve that by using the equation length times width times height. This is what I would do for objects that look like this, and only objects that look like this. Okay, like I said again, you cannot use this method for something like this. Okay. All right. So the third and final way that we can find volume depends again on what type of object that you are measuring. So in this case, we're now going to go to irregular shaped object. In other words, it's not a liquid. because we learned that a liquid, you use a graduated cylinder. All right, it's not a box shape like this, but it's more like this, where it's irregular. All right, it's not a liquid, so I can't just put it into a graduated cylinder and measure it that way. And it's also not a box shape, so I can't use my ruler, right? I can't use this to figure this out. So what we'd use is a method called water displacement, all right? And if you look at the picture right here, you can see what water displacement is. So what you do is you use a graduated cylinder. So you have to use, again, just like you would use a liquid. But instead of just putting the object in there like this, what you do is you first fill it up with water, all right? And you fill it up to a certain point. And then what you do, so like in this picture right here, shows that you start at 7, right? And then you put the object into the graduated cylinder, and you see how much the water rises. That's called water displacement, right? If you've ever drank like water and you put ice cubes into your cup, you'll see that the water level rises. It's the same idea, is that every object has a buoyant force, all right? So it's going to make the water level go up. And to find the volume of an object, you want to see how much does that water level go up. So in this example that I've shown you, it goes from 7 with nothing in it. So when I put this object in here, it goes from 7 to 9. That means that the water level rose 2 milliliters. That means that the object has a volume of 2 milliliters. Okay, so now what does that look like now if you were trying to accomplish this? So if I move my camera over here, right, and you'll see that the same rule applies as to, when you're using a liquid, you want to use the object that's going to fit into the smallest graduated cylinder. So for example, if I wanted to use, like, say, the 10 milliliters, but this object doesn't fit inside of it, right? If I try to do that, so that means that I can't use the 10 milliliter. So bye. All right. Now, the next thing I look at is, does it fit inside the 25? Yes, it does. So that means I don't need the 50 milliliters because this is not as accurate. So bye. All right. So now I'm ready. And I know that you guys, and I'm actually going to blow this up so that you guys can see it better, right, is you can see that, and I'm not sure if you quite can see the number on there, but it's at 10 milliliters right now, all right? I've measured that out. So what you want to do is you want to previously measure it out, and then what you want to do is you want to tilt this because you don't want to just drop it in. If you drop it in, it may splash some of that water out, and we don't want that. So now it went in, right? So now if I read the new reading, so if I look at it, it's at exactly 14.5 milliliters. And again, I know that you can't see it perfectly, but I can. So I'm going to look at it, and I see 14.5. So it started at 10, right? And it moved to 14.5. That means that my piece of clay right there that I had, that irregular shape, is now at 4.5. It has a volume of 4.5 milliliters. Because all I did was what I subtracted. I subtracted the 14.5 minus the 10 that it started, because it rose 4.5 milliliters. Okay? And that's how you would find the volume of an irregular shaped object is inside of you still need to use a graduated cylinder, but what you need to do is you need to find how much the water level rises. And that's how you find the volume of an irregular shaped object. All right? And that's the 3 different methods that you can use. And that's, you can look at me again. All right? To find the volume, those 3 different methods. So it's length times width times height, using a graduated cylinder, and then water displacement.
So now let's start talking about what makes an object sink or float, and we'll get back to how mass and volume affect that, right? But the thing that really we talk about is about density, and this is another vocabulary word, and you might have not heard this word, but basically it means the definition is amount of mass per unit volume. But really what that means is how tightly packed is that object, right? How tightly do you pack that little shape, right? So for example, if I look at these 2 right here, right, which one looks like it's more tightly packed? I hope everybody believes that this one looks like it's really tightly packed. This object is more dense. okay? Because it's very, very tightly packed, all right, while this one is less dense. There's a lot of space in between, okay? And that's going to be very, very important to understand why objects sink and float, all right? So this one has a lot of space. If there's a lot of space, all right, there's a lot of air, that means that, you know, it's not very, very dense. It's very, very, I don't want to use the word light. It's very, very stretched apart. It's not tightly packed, okay? So now how does that make a difference? So when we talk about that, what makes an object sink or float is its density. I know a lot of you guys want to say, oh, that object is lighter, so it's going to sink. Well, then if that was the case, then why would a penny sink and a big giant boat float? Right? It doesn't make any sense. A boat is a lot heavier than a penny. Okay, so it has nothing really to do with the weight of an object. But what it really matters is it's the object's density compared to the liquid's density. So if the object is more dense than the liquid, it's going to sink. Right? And if the object is less dense than the liquid, it's going to float. And that's the reason why you see objects sink or float. And we'll talk a little bit more about this. Okay? But I really want you to understand that mass and volume alone, right here, don't matter. Okay? You can't say, oh, that object is really, really big. It's gonna sink. Right? Or that object is really, really heavy. So it's going to sink. It has nothing to do with that. Okay? And a boat is a prime example. Boats are very, very heavy. They're very, very large. Yet they find a way to float. All right, so it's all about the density of the object that really makes it that much of a difference. All right, so it's really, really important to understand that concept. And again, we're going through these notes very quickly, so we'll have more time to kind of go through all this stuff through the labs that we do and stuff. Okay, so now, just like last unit, there is an equation. And the equation that we have is the density equation. So, right, we're going to make sure that we know this one, right? I'm going to highlight it. I'm going to do whatever I can to make sure that we understand that this is the equation that you need to know. Density equals mass divided by volume. And the way you're going to see me write it is it's going to be D equals, mass divided by volume. Okay, D equals M over V. All right, so we can calculate density by finding mass and volume. And that's the reason why we started off by talking about mass and volume, because if you can find the mass of the object and the volume of an object, you can find the density. And if I know the density, I can predict whether or not an object is going to sink or float without even having to put it in the liquid or in the water or wherever I'm going to put it into. I can do that. And we're going to practice doing that so that you can predict whether or not an object is going to sink or float. All right, so we're going to use this equation. Right now, just like last unit, right, we're going to use this equation to solve certain problems. So just like last unit, you're going to have to show your work when you're doing all this kind of stuff. So same thing as last one, right? When you get a word problem that says your shoe has a volume of 1,250 milliliters and a mass of 350 grams, what is its density? What you're going to be able to do is first, you're going to show your work. So just like last unit, right? I'm going to put D equals M equals V equals. So what do I know? And I'm going to put a question mark next to D equals because it says what is its density? Right? And then I know my mass and volume because my word problem says 350 grams. Right? Is that? So this is step one again. Remember in the notes. So step one. Right? And then 1,250 milliliters is my volume. Step two, if you remember from last unit, is write out the equation. D equals M over V. And I always want to see this work in your homework or even on the quiz when you're doing it. All right? And then after that, it's really, really simple. Third step is just plug in the numbers. So the numbers are D equals mass, which is 350 grams, okay, over the volume, which equals 1,250. Okay, so when I do the math on that, I believe it's something like 0.37. Does that sound right? Okay, and that is my answer. and I circle it or frame it so that I know what the answer is. And that's really easy. So like the math that we're doing is not any different than last unit. Okay? Just like last time that you have to do. So density. And then there might be some other word problems where you have to find the mass, where you have to find the volume, and you have to rearrange the equation to do all those things. Okay? So that's